Stress-free learning with
Nyam.
create a better tomorrow. You get the program. Hard work pays off, so come and put it in. No need to wait, let the lessons begin.
Failure is the best thing that could happen to you, because it means that you have tried and now you can learn from that and be better next time when you try again. Boom. Okay, today what are we doing? Today we got three things that we'll be doing. We'll be doing tangents of functions, stationary points, and points of inflection, right? So let's get started. Let's get right away with tangents of functions. You know what a tangent is? A tangent is a straight line that touches a graph at only one point, right? So since this is a tangent of functions, it'll be a straight line that goes through only one point of that function, right? So another thing to know about tangents, right? The gradient of another thing to know about tangents, right? The gradients of another thing to know about tangent, right? The gradient of a tangent is equal to the first derivative of that function, right? So what am I talking about? Okay, let me do some visuals so that you can see what I'm talking about, right? So these are the two equations that you'll be using for tangents, right? So of course there's this formula that you already know, y is equal to mx plus c. You should already know this formula here. So of course when you're dealing with straight lines, we know that we use that formula there. But there's also a second formula that you can use. Okay, so this is your second formula. You have y minus y1 is equal to mx minus x1. So these are the two equations that you can use to find the equation of a straight line, right? So in this case, the equation of a straight line of a tangent, right? So what did we say? I said that the gradient of a tangent is equal to the first derivative. Okay, let me write that down. What I mean is f prime of x is equal to, what is f prime of x equal to? F prime of x is what? The first derivative, right? Because we only derived it once. F prime of x is equal to gradient. What is gradient? Gradient is also equal to m, right? So f prime of x is equal to the gradient of that tangent line, which is equal to m, right? So let's do an example to see visually what I'm talking about, right? So my example 1. Okay, given that the graph of g of x is equal to x squared plus 6x plus 8, right? Now it says determine the gradient equation at the point x is equal to -1, right? So this is my question. My question is asking, determine the gradient of the equation. My question is asking determine the equation at x is equal to -1 of the tangent line. Okay, determine the equation of x is equal to -1, determine the equation at x is equal to -1 of the tangent line. Determine the equation of the tangent line at x is equal to -1, right? So what's the first thing that we do? The first thing we do is we apply what I just told you about over there. I just said f prime first derivative is equal to what? The gradient, which is equal to m. So let's find the gradient first, because we know in a line you need the gradient. In this equation, either one of these equations, you need a line. You need to know what the gradient is. So let's do that. So f prime In this case, it's not f prime. In this case, it's g prime of x. What is g prime of x? G prime of x equal to? It is equal to, again, if you are still unsure about derivatives, you need to go back and practice on them. So this would be equal to 2x, 2 minus 1 becomes 1. So we don't need to. I hate it when people say, if I were so and so, I would do this and this. Stop it. Stop putting yourself, stop trying to live other people's lives. Focus on your life. Because that's the only one you can control. Focus on you. What would you do in your shoes? What would you do? Write that one. It's just a 1. We know that it's a 1. Plus 6. Because it will be 1 times 6, which is 6. 1 minus 1, which is 0. X to the power 0 is 0. Is 1, sorry. So, and then the derivative of 8, which is a constant, is 0. Right? So, now we have g prime of x. What did we say g prime of x is? G prime of x is also equal to the gradient of that tangent. So, we know what this is our formula that shows us the gradient. This is the result. So, but we want n value because we can't put 2x plus 6 into that equation. And no, do not make the mistake that the coefficient of x is the gradient. No, the gradient is equal to the first derivative. So the whole thing. So what does that mean? It means that for me to find the gradient, I must put in the value where I'm looking for the gradient for. So I'm looking for the gradient equation at x is equal to -1. So I'll input -1 inside this equation, right? Then now I have 2 times -1 plus 6. What is that equal to? This gives me 4, right? So, okay, this which will result in number 4, right? So what does that say? It says that my gradients is equal to 4. So now what do I do? Now I'm stuck, right? Am I stuck? No, I'm not stuck. Why? Because what do I have now? Now I have the gradient. Once I have the gradient, what do? I will substitute into one of my equations. I can either use this one or I can use that one there. But in this question, I want to use both of them to show you that both of them lead you to the same exact answer. Right? So, what's the first thing I do? First thing I do is I'll write the formulas down. Y is equal to mx plus c, or y minus y1 is equal to mx minus x1. Okay, so for this one here, what do I need to solve for first? Because I have the gradient and I have an x coordinate. So what do I have missing? I have c and y missing. Which one of those unknowns can I find at first? I can find the y coordinate. Why? Because I can find whatever y coordinate is corresponding to that x coordinate. So therefore, what do? I input that -1 into, no, not into the first first derivative, no, into the original equation, because I want to find the coordinate. So what do? I say g of -1 is equal to, g of -1 is equal to what? So -1 squared is 1, minus 6 gives me -5, plus 8 gives me +3, right? So my coordinates is -1 and 3. That's my points that I have right there where they gave me the x coordinate of. I can find the y coordinates. So now I have that. Once I have that, what can I do, right? I can bring it back here and plug in all the values I know. What do I know? Do I know the y value? Yes, I just calculated that. It's 3 is equal to what? Do I know what the gradient is? Yes, I calculated that. It's 4. Do I know what the x coordinate is? Yes, I do. It's -1, right? Plus c. So now what do I solve for? There's only one unknown in this equation, and that is c. So now for me to solve for c, I'll just take the -4 to the other side, so it becomes positive. So it becomes 4 plus 3, which gives me 7, right? Yes, it gives me 7, right? So now I have that. So I can write this equation out. So I can write y is equal to 4x plus 7, right? So I have solved it using this equation. Pretty straightforward, right? This is the equation that you are comfortable with, that you have been using most of the time when you do these type of things, right? So now what do I do? What do I want to do? I want to use the other equation. If you can tell already that it's pretty much the same thing. It's just, it looks different. So this one here, y minus, do I know a y coordinate? Yes, I do. I know the y coordinate. That's where the tangent is, which is negative, positive 1, so it becomes y minus 3 is equal to, do I know what the gradient is? Yes, I calculated it and it was 4. And x minus, right? Minus x1. What is x1? Do I know an x coordinate? Yes, I do. Excuse me 1 second. It's negative 1, so this becomes positive 1, right? Why do I not replace y and x? Because I want to write the function in terms of y and x. So the only coordinate that I replace is the one where it's y1 and x1. Or you can rewrite it as ya and xa. Or whatever, however you want to write them. But you do not replace the y, that is nothing, no little asterisk at the bottom, or the x with nothing at the bottom, right? So you replace all the parts where it's y1, the second y1 and the second x1, right? So now what do I do? Now I can solve for this. Am I solving for a variable or am I writing it as a formula? I'm writing it as a formula because as you can see already, it's already a format where we can work with. So what is my formula equal then? I say y is equal to, I'm going to take the 3 onto the other side. So on this side, I already have 4x plus 4. Then if I take the 3 onto the other side, it becomes plus 3, which gives me 4x plus 7, right? So if I look at my both equations, my equations are exactly the same. They are identical. What does that mean? That means both ways work the same and give you the same result. So that is basically it on tangents on functions, right? So basically, let me draw you a visual. It might be, let's say my graph is something like this. Right? Let's say, for example, that's my graph, right? And let's say find the tangent at negative 1. There is negative 1, right? That's the negative 1x, right? And then that will be 3 out, since we calculated the y value. And then that right there is the tangent, right? That right there is the tangent where we just calculated the equation. So this line there, that's the line we just calculated the equation for. So this will be 4x plus 8. But again, don't look at my graph. It's not necessarily accurate. It's just a graph to represent what I'm talking about. So that's basically what we were calculating right here. Okay, so that's it with tangents of functions. So let's move on to stationary points. Okay, stationary points. What's another word for stationary points? It's a turning point. What is a turning point or a stationary point? It's the same word. It means the same thing. This basically is what a stationary point is. Okay, a stationary point is a point where the graph changes from decreasing to increasing or increasing to decreasing. That's basically what it means. So, example, this point here is a stationary point. Why? Because the graph is increasing until it gets to that point there. And then it starts decreasing once it hits that stationary point or turning point, one might call it. So, what they might write it as TP, turning point, right? Or stationary point. So, what's another stationary point that we have here? Another stationary point we have is this one here at the bottom here, right? It's normally called local minimum. That's what it usually is called, right? So that's another turning point. This graph, it's going down. So what is that? That's decreasing to increasing. So at that point, we have a turning point. And what's to note about that? The very important thing that you'll be using all over the place is that at a turning point or a stationary point, the gradient is equal to 0. What is the gradient again? The first derivative. First derivative is equal to 0. So what do I mean by that? I mean f prime of x is equal to 0. So if this is a function of f, right? If that is a function of x, of f, right? F of x, let's say, then f prime of x at both of these points would be, at those points it would be f prime is equal to 0. You will be using that a lot when you have to solve for most of these equations, right? Okay, so let's look. Another thing to note about this stationary point and anti-stationary points is if f prime of x, right? F prime of x is greater than 0. It means, what does that mean? Of course, if you look at it logically, it means that the graph is increasing. Stay right here. Look, focus. Where you going? Come back here. Come back. Where you going? Come back. You're not done. I'm not finished. Okay, you can go out. Just joking. No, I'm not joking. Come back. Right? That's what it means. So if f prime of x is greater than 0, it means that the graph is increasing. And of course, the other way works too. If f prime of x is less than 0, it means that the graph at that point is decreasing. Alright? So you might be asked some of those questions. So you need to be aware of that little bit of theory, so that you can apply it and get your marks for free, right? So let's do an example to see what I'm talking about. Okay, so what does my example read? My example reads, if g of x is equal to x squared plus 4x plus 4, find the turning point and also find if the function is decreasing at x is equal to 1. So let's break it up and start with the first question. The first question says, find the turning point. So what, does that look complicated? It might look complicated, but it's not that hard. It's pretty straightforward, right? If you think about it. What did I say? What was the rule that I stated first that I said you will use a lot? I said that f prime of x is equal to 0. What does that mean? It means that at a stationary point, the gradient is equal to 0. So let's use that. Let's write it down first. Let's write f prime, but in this case, g prime of x is equal to 0, right? So what do I have in this equation that I don't know? G prime. What is the first derivative? So let me find that. So if I go g prime of x is equal to, again, I need to derive this. Get comfortable with your derivations because you will need to use them a lot, even when you finish school. So we have 2x plus 4. That's my derivation. That's what g prime is equal to. So I have 2x plus 4, right? So what did my rule say below, just before this? I wrote g prime of x is equal to 0 at a turning point. And what am I looking for? A turning point, right here. Turning point or stationary point, whatever you want to call it, right? So what does that mean? It means I will equate this to 0. Why? Because I just stated it right here. So now what do I do? Now I solve for x. So I will have 2x is equal to -4, x is equal to -2, right? So x is equal to -2, right? That is my x coordinate of my turning point, right? So I already know the x coordinate of my turning point. So now I want to find, because it's a turning point, I need two coordinates, an x and a y. How do I get the y coordinate now? Do I substitute it back into this equation? Try that and see what happens. If you substitute it back into this equation, you will get 0. Why? Because you just worked to solve to equate to 0. So you do not substitute that x value into your first derivative. You substitute it into your original equation, because you are saying that that point there is that point there. It's this point here. That point there, that's x is equal to -2. That's the point, that's the x coordinate we just solved for, right? So now we need a y coordinate. For a y coordinate, what do we know? We know that it's on the graph. If it's on the graph, what does it mean? We can just substitute into the original equation, g of x. So if we substitute into the original equation, what do we get? So if we substitute g of -2 is equal to -2 squared plus 4 times -2 plus 4, right? Which is equal to, what is this equal to? This will equal -2 squared gives us 4 4 minus 8. 4 minus 8 is negative. 4 minus 8 is negative 4, and then negative 4 plus 4 gives us 0. That looks weird, doesn't it? It looks strange. So, what does it mean? Let's write it down, 0. So it gives us, so now we know the coordinate. The turning point is equal to negative 2 and 0. Right? So what does it mean? Of course, this graph and that graph are not exactly the same. So what does it mean? It means that this graph here is more likely to look something like this. Or the other way, upside down. But anyways, as long as one of your turning points is touching the xy line, right? So what it means is that the turning point occurs. It occurs at the x-axis. So we have a turning point at negative 2 and 0, right? So we have a turning point and point of intersection and the x-intercept in the same place. We'll speak about that a little later on. Again, my graph is not exactly what that graph is supposed to look like. It's just a representation to show you what I mean by saying that this point here is a turning point, because it turns on the x-axis, right? So let's answer the other question. It says, find if the function is decreasing at x is equal to 1. So what do we do? What did I say above? I said that if f prime of x is less than 0, it's decreasing. And if f prime of x is greater than 0, it's increasing. So naturally, what does that mean? It means that I have to find out at f prime of x whether it's positive or negative. Is it above 0 or is it below 0? Let's find that out. So I'll substitute in my coordinates. So g prime of 1 is equal to, right? Can I put this x into the original equation and find out if it's decreasing? No, I can't, because g prime of x does not determine whether a function is decreasing or increasing. It's just to sketch the graph. But I know that my rule says that f prime of x can determine whether a function is decreasing or increasing. So if f prime of x is greater than 0, increasing. If it's less than 0, decreasing. So I'll substitute into my g prime of x. So it becomes g prime of 1 is equal to, what is my equation? My equation is 2x. So it'll be 2 times 1 plus 4, which gives me 6. It gives me 6. Now, let's go back to grade 2. Is 6 greater than 0 or is it less than 0? It's definitely greater than, right? By the looks of it, I think 6 is greater than 0. So what does that mean? It means that if f prime of x is greater than 0, it's increasing. So my graph is no, it's not decreasing. To answer my question, no, it's increasing. Right? So my graph at that specific point x is equal to 1, my graph is increasing. Right? So we found what the turning point is, and we found what we determined whether it's increasing or decreasing. And also over, let me write, this is increasing and this is decreasing. Right? So everything should be clear to you now, right? This was easy. This is 3 marks, and this will be a question in your paper. So be comfortable with it, know how to do it. Be comfortable with your derivatives. You will be using them all over the place, right? So let's go on to the next part, which is concavity. Let's discuss a little bit about concavity. What is concavity? Concavity, basically what concavity is about, it's about this. This is concave what? This is concave down. And what is this? The one from there to this way. That's concave, concave up. So basically, let me write it on this side. If you have a smiley face, that's concave, that's concave up. And if you have a frowny face, that's concave concave down, right? So this is smiley, and this is sad, right? So that determines whether that's concave up or concave down, right? So that's basically what concavity is about, right? Easy stuff. And you might get a question like that. So if they ask you, they say, is the graph between this point and that point, what concavity is it? It's concave down. Why? Because we have a frowny face. It's facing down. It's concave down. Okay? So now let's look at points of inflection. Points of inflection relate very well with concavity. And you'll find out why just now. Okay, so points of inflection. What is a point of inflection? A point of inflection is a point where a graph changes from concave down to concave up, or concave up to concave down. What does that mean? Okay, let's look at our graph again. This is concave down, right? The one at the first part of this graph. It's concave down, and then it goes to concave up. So what did I say? I say from concave down to concave up. Work hard and play hard. I live by this. Get your work done. When you are working, you are working. And when you are playing for real. So get yourself in that mentality where when you are doing work, you are only doing work. You are not on any social media. You are not doing anything else. There is a point where it changes, right? So let's say, for example, that point is here, where it changes from concave down to concave up. That is the point. So what is that point called? That point is called the point of inflection. Point of inflection is changing from concave up to concave down, or concave down, in this case, to concave up. Okay, so that's basically what that is. So point of inflection. Point of inflection, how do you find it? Right? Point of inflection is determined by the second derivative. The second derivative, what is second derivative? F double prime. F double prime, what does it mean? It means that we derive twice. What does that mean? It means that the first equation, like right here, this is the first derivative. I derived it once, but I can derive that equation again. What does that mean? I can derive it one more time. I can say g double prime of x, and then I derive it and it becomes just 2. I hope you get what I'm saying. If I derive this equation again, it becomes 2, right? Because it's 1 times 2, which is 2. And then we have in the exponent 1 minus 1, which is 0. And then x to the power 0 is 1. So we only left with 2. And the derivative of a constant is still 0, right? So that's what it means. So if f double prime is equal to 0, it means that there is a point of inflection at that point, right? So what other things can we determine that are similar to this? There are similar things is if f double prime of x is greater than 0. Okay, again it's the same thing. If f double prime of x is greater than 0, it means that the curve at that specific point is concave up. So concave right? It's concave up. And if it's concave up like this, if it's concave up, it means that we have a local minimum point. Wow, what does that mean? It means that we have a low, that's the lowest point. If we have a concave up, we have a local minimum point. Why? Because it starts like this. So the maximum point is a minimum point. It is not a maximum point. Right? Because there's still more points above, but there are no points below that point. Right? So let's look at the other one. If we have, well, you can probably guess now, if we have the f double prime of x that is less than 0, what do you think that means? It means that that is concave down. Right? So it will be concave down, it will be that point there. So if f double prime is concave down, it means that that is concavity going down. That's a sad face, right? So let's write that down. This is concave right? So that's basically what it, and if it's concave down, what does it mean? It means that we have a local maximum point, right? Because there's a point, if it's concave, if it's a sad face, it's facing down. So there are only points below it, there are no more points above. So it'll be the maximum point, so it's a local maximum point, right? So that's basically it on points of inflection. Let me write it up. Points or point of inflection. Right? So this topic is points or points of inflection, which can also be written as P dot 0, right? Because point of inflection. You can shorten, you don't have to write the full thing every time, right? Ignore my underlining. It's a little skew, just a little bit. So that's basically it. So now let's do an example, right? So that you can see what I'm talking about. So it says find, okay, that's my example. My example on points of inflection says find the point of inflection for g of x is equal to 2x cubed plus 2x squared plus 2. It's a little squash over there. I don't know what happened. Should have planned it over more effectively. But yeah, the equation says 2 of x cubed plus 2x squared plus 2. Now it says find the point of inflection of that. What does it mean? What do I remember about point of inflection? Point of inflection is found where if double prime of x is equal to 0. So let's do that. Let's find the first derivative. So in this case, g prime of x is equal to. So for me to find f double prime, I first have to find the first derivative. I can't jump to the second derivative without finding the first derivative. So first I find g prime of x, the first derivative. This will be 6x squared plus 4x, right? 4x plus 2. But 2, derivative of 2, which is a constant, is 0. So what do I have? I have 6x squared plus 4x, right? So now at this point, what do I do? Now, because this is not, I'm not looking for what's the first derivative what can I find with the first derivative? I can find the turning point or the stationary point. But in this case, I want to find the point of inflection. So it's equal to the second derivative. So this would be g double prime of x is equal to. What is g double prime of x equal to? It's equal to the derivative of the first derivative. So this will be 12x, right, plus 4. Right? So what do I have? I have 12x plus 4. Right? So now, what did it say? G prime of x. The above equation says, if only you can find the point of inflection when f double prime of x is equal to 0. So what do? I equate this to 0. So if I equate that to 0, I can now take the 4 to the other side, so it becomes negative 4. And if I divide negative 4 over 12, it becomes negative 1 over 3. Right? So what do I have? Now that's my equation. That's my answer. That's my x coordinate. But point of inflection, it's a point. So I need two coordinates, an x and a y. So what do I do now? Do I substitute it back into this? No. Do I substitute into this first derivative? No. I substitute it into the original equation, because again, that point is on the graph. Once I have the x, I can just substitute the x coordinate and then find the y into the original equation, which is g of x, right? So if I say g of negative 1 over 3, what does that result in me? So this will be 2 negative 1 over 3 cubed plus 2 negative 1 over 3 squared plus 2, right? My answer, which I get, is over 27. 58 over 27. So basically, that is it. That's point of inflection, and my point is and that is my point of inflection. Basically, simple marks, easy marks. I can get these in my sleep. Right? Go get those blocks now. Okay, go watch the next video. Okay, boom.